Hey everyone. So it was really wonderful to get to hear from Jan LeCun, and now my name is Sara Beery. I'm a professor of AI and decision making here at MIT, and I'm going to kick off our next session, which is 3 different talks about the use of generative AI across scientific disciplines. And so I'm going to kick us off here, specifically talking about generative AI in the field of ecology. So in my research group at MIT, we sit fundamentally within the AI cohort, within the AI discipline, but we consider ourselves truly interdisciplinary scientists. I've been working in the ecological applications of AI for over a decade. And in general, our large goal is we want to be able to understand and monitor biodiversity, all life and the interactions between life on Earth, and be able to detect change in biodiversity, risks to biodiversity, across scales, globally, and in real time. Now, this is a very ambitious goal, and I am not the only one who has this goal. And in recent decades, the combination of sort of advances in hardware and sensor technology that help us capture much, much more data than we'd ever seen before across many, many different types of data, everything from satellite images to cameras on the ground, bioacoustic sensors, environmental DNA, where we can collect evidence of species even if they no longer actually are there in the environment, and increasingly things like community science, so organizations like iNaturalist that help any of you, any passionate volunteer, contribute species data to our scientific understanding. This data is incredibly valuable and has really expanded exponentially. But the problem is, none of these data types are directly measuring what we care about. Unlike if you're interested in measuring surface temperature, which is a measurable quantity. Instead, we get pixels, we get sound waves, we get point clouds, we get hyperspectral data. And then we need to actually figure out how to translate those streams of raw data into some form of actionable insight, some form of scientific knowledge about the world. And this is really where AI has already been absolutely transformative. We've seen models get deployed for many of these different data types to be able to turn that into scientific knowledge. Now, one of the big challenges that we have is that ecological imagery is often highly degraded, right? Unlike data that's captured by a human photographer, where maybe you're using your own intelligence to get a photo that captures the thing you care about, is reasonably well lit, is focused, is well centered. If you're collecting data from all of these remote sources, what you get is data that can often be very difficult to interpret. It can have haze, it can have noise, it can have occlusions, we can deal with weather challenges. And so what we've been trying to do in our lab as one of the many different diverse applications of generative AI is figure out how to address the challenging noise, these compound degradations of data for ecological imagery. And so what we've proposed is a method that we're calling PRISM. It stands for Precision Restoration with Interpretable Separation of Mixtures. But at its core, it's essentially an image generation model that takes in both an image and input from a scientific expert and is able to iteratively remove these distortions with a focus on scientific accuracy. So there's a lot of work in image generation that we've seen, but one of the challenges is all of our metrics in the AI space for image generation seem to be grounded around the idea of like human perceptual value. We want things that look pretty. I don't care if it's pretty, I want it to be correct, right? I don't want pretty at the expense of correct. And so what we've done is we've really focused on sort of 2 key components. We recognize that we're going to have complicated compound distortions, so we train the model on the types of difficult distortions we're going to see in reality, and we actually have built this contrastive latent space that helps us separate the different types of distortions and learn how to deal with them interactively and independently, which then means that we can almost see them as like pieces or tools that we can put back together to be able to try to get to the correct version of an image. So the cool thing here is that now with our system, we enable both controllable and joint restoration. So you can restore multiple types of distortion, and you, as a scientist, are in control. So let's look at this satellite image, for example. So you can see here, this is a satellite image taken of the Earth And we're looking here, I'm highlighting this area because I think it's a nice place to look at. And there's two different types of distortions that are affecting our ability to see what's going on here. We have both clouds and low light and noise. So 3. So one thing you could do is you could try to, with this kind of controllability, by prompting our model, remove each of these types of distortions independently. So you can try to remove noise, okay, you get something kind of diffuse. You can try to remove the clouds, all right, now we have some blurriness, but we are kind of anticipating what might be underneath. We can try to remove low light. And so, okay, we can see, like, yeah, we've done something. Is it correct? That's the interesting question, right? How do we know that this generated image is actually correct? So here, what we've done is you can think of this like sequential restoration, but our model actually enables composite restoration. So we can do all of this simultaneously, which is much more computationally efficient, and we find actually also introduces less artifacts. You have less opportunity to add incorrect information. And if we look at the true clear image, which we've collected from, basically we've come up with this really nice way to evaluate the models where we use difference over time to find the true value of what we actually want to recover. So we can evaluate on truth, not quality. We can see it actually is a really nice match, both qualitatively and quantitatively. And this cool thing about controllability is that it enables you as an expert to drive scientific precision. So like I said, the more you change, kind of the more opportunity there is to add mistakes in these generative models. One thing that has been brought up a lot is this idea of hallucination. But yeah, generative models can introduce errors. And what we've seen is that if the goal is to be able to do some sort of scientific inference downstream, you don't always need to remove every type of distortion to be able to do your task correctly. So in this case, what we're showing is that an expert identifying that we want to just remove the contrast, but we don't necessarily want to also try to affect the low light is better. And the way that we're actually showing that is these are camera trap images, and we're trying to identify species. And I bet all of you don't necessarily even know what's going on in these images. That's because you're not an ecologist or a scientific expert. And this is really where that expertise comes in. So here, there's clearly an animal, you can see its eyes, and that part in the red box is its tail. And what we're showing is that by only removing the contrast, but not also trying to change the haze, the low light, all of these other distortions, you're better able to pick up the stripes on the tail, which enabled an ecologist to correctly identify this as a northern raccoon. And again, we're identifying correctness, and we're doing that by using changes over time. So an additional image in this sequence, which had a much easier to identify species as our way to evaluate. So you can see this for other types of modalities too. Here we're looking at microscopy, and you can see that if you're trying to segment out objects here, if you just do it on this low resolution sensor, you miss some stuff. You can do super resolution, and here, okay, just by super resolving, now you have some additional objects. If you try to super resolve and denoise, you've removed those objects. So here you can focus specifically in this area, right? You can see there's 2 objects here that have been removed. Now if we compare this to a high resolution sensor that was actually taken of the same thing, so we know that this is ground truth, you can similarly see by kind of carefully removing or addressing only some of the dimensions of the data quality challenges, we get much more scientifically accurate results. And so the other cool thing is that by disentangling in the latent space, by taking all of these different types of distortions and learning them independently, this means that our model is able to generalize in some ways to types of data, types of scientific data that it never saw during training. So for example, this is a drone image of a reef, so this was taken over a coral reef. And you can see that with an expert in the loop, you can unwarp the wave distortions, you can fix the coloration, this kind of distortion of the color that you're seeing through the water, and you can unblur. And based on undersea imagery of this, the ecologists thought that this was a much significantly more improved version of the data. And the nice thing is, using our method, you can also do this without an expert in the loop, and it does work okay, right? So you can identify types of distortions that the model thinks might be in the image and remove them for things like images of species on the ground, again, underwater ROV images, so now instead of above the surface, below the surface, or the ability to even, remove the surface of rippling water. And so I think this is it's just a first step, but there's kind of a few key components I want to emphasize here. First, I think that generative AI across many different dimensions is really going to be fundamentally a transformative tool for science. But I also think that there is a key piece of understanding, which is I think it's a tool. And I think the hard-won knowledge that scientists have built through decades of training is also adding value. And so I like to think about how do we design these systems so that scientists can work interactively with these tools, but the scientist is still the one who's in control. The scientist is the one who's able to do that verification, use their intuition to ensure the correctness of what they're trying to measure. So thank you very much. And of course, I'd be remiss without thanking the many, many collaborators in the ecology space that have contributed to my group's work at MIT. Thanks.
As you have seen, I'm currently the Vice Provost of Open Learning. My name is Dimitris Bertsimas. I have joined Open Learning a year ago. I've been at MIT about 40 years. And one of the reasons I joined Open Learning is to try to work with colleagues, students, and so forth, to accomplish the dream of personalized education. What I'm doing today is far from personalized. All of you see a common lecture, even though you have many distinct characteristics. So if somebody would have told me that, that in a year or so, I would have been able to talk about some of our progress, I wouldn't have believed it. So the word magic is relevant. I hope you feel the same in the end of the talk. So this is a vision and our efforts on creating a customized, adaptive, online education using GenAI. This is work with two of my exceptional students, Romain and Di Wang, who are starting their second year at the Operational Research Center. So online learners have obviously different interests, backgrounds, and goals. So as a result, this calls for customization, adapted to these characteristics. First motivation. Also, learners have different learning pace, abilities, and preferences. This calls for, naturally, for personalized adaptive learning. This is so far from the point of view of the learners. However, the people who create all the context are professors, teachers. So improving instructors' productivity to fulfill these needs while retaining control is also relevant. And I will show you the progress we have made on all these three areas. So one of our efforts this year in Open Learning is what we call Universal AI, which is about to launch in a week or so. This is an ambitious program of reaching a lot of learners in the world, of teaching the basics of AI. So this is an example of once, this is me in a particular topic. Let me give you some of the details of multiple linear regression model. We are given data of the dependent variable yi, the price realization of auction I. So let me show you how GenAI can customize this content automatically for the healthcare industry. The previous was about auctions.
Let me give you some of the details of the multiple linear regression model. We are given data of the dependent variable yi, the hospital length of stay in days for patient I, and independent variables x subscript I.
Similarly, for the energy industry, I would like to stress that this is automatically generated with a very single command.
Let me give you some of the details of a multiple linear regression model. We are given data on the dependent variable yi, the day-ahead electricity price in market interval I, and independent variables x subscript I superscript 1, the system load forecast in MW, xi2, the natural gas spot price in USD per MMBTU, xi3.
Now I would like to demonstrate to customize the length of a presentation. So the previous were more elaborate presentations, and quite often the need arises for a much shorter bite.
Here's the 30-second summary. We model log wine price as yi equals beta plus beta 1 x1 plus e, fitted by minimizing the sum of squared errors, SSE. R squared equals 1, Maes SSE SST measures how much better we do than predicting the overall average only. Using age, temperature, and rain as predictors, a simple model reaches R-squared to 0.42 on Bordeaux data and beats the average baseline. Takeaway: a few variables plus linear regression yield useful, quantifiable forecasts.
So now I would like to demonstrate the need to customize simultaneously the language of instruction as well as the domain expertise, right? Of course, there are multiple other combinations. This is just an indication.
Permítanme presentar los detalles de un modelo de regresión lineal múltiple. Disponemos de datos de la variable dependiente I, la rentabilidad diaria en %, del activo financiero analizado en la observación I, y de variables independientes, X =
So, I mean, I don't know Spanish, but I checked with one of my students, and the assertion was that this is okay. I was worried about that. So now I would like to say the bigger dream. So far, this was the customization adaptation story. But suppose you have the following. Suppose you have a lecture, as we do in Universal AI, in which you have an assessment. After 5 slides, you have a brief assessment that can be done in a few seconds. This is an example where the student clearly does not understand what R-squared is and its values. The specifics is not so important to understand, but the key here is that it's very simple to detect that the student didn't fully get it. So therefore, a need arises for a system to perhaps review and repeat the story in an understandable way, targeted for the story.
The key performance measure in linear regression is called R-squared. R-squared is defined by calculating 2 quantities. First, the sum of squared errors, SSE, which is the sum of squared distances of the points to the green line.
And this is something what we actually are currently implementing in open learning to do it in a very customized way, adaptive to the learner in a personalized manner for all the content that we have. Final, how to put the instructor in the loop. So what we have built and what we envision is that the biggest bottleneck in high-quality educational content is the time of my colleagues as well as mine. So this we expect will help accelerate the story. So a human in the loop, an instructor in the loop. So the idea is, so this is a system that the instructor can give some instructions, also what information, what papers, books, slides to use, and then appropriate instructions to synthesize the story. Clearly, we don't have a lot of time to demonstrate all the details, but we do envision that this could be, we have a working prototype, a tool that we are currently experimenting within open learning with various instructors responsible for various paths. So although, of course, this is still in a research environment, it's a prototype only, but it is our aspiration within open learning to utilize all these features in everything that we do. Our first step is we're about to launch Universal AI for we hope, a lot of learners. And that will be, in a way, our first experiment. We, of course, will adapt and learn, but we envision that the idea of customization for different audiences, for different industries, the idea of personalization, and the idea of translations, adaptations in length and difficulty is going to be present. So I would leave you this vision of customized, adaptive online education. As I mentioned, when I have worked in the area of personalization, I tried anyway, 10 years ago, and it was an enormous effort. In the topic of linear regression, we have developed in the past various paths for learners. Just for one lecture and one homework, it took myself and a student months to do. this is not the case. This is, I believe, that's why I said if somebody told me a year or two ago, I would say this is probably science fiction. And this happened within a year. Of course, it wouldn't have happened without the ability and talent of my two students, but my hope is that this will change education in ways that I think will be beneficial to learners, and perhaps in the way even MIT or other universities around the world will be adapting to this new knowledge. Thank you.
So we're all used to seeing graphs like this of AI's capabilities improving over time. This doesn't even show the last year, and Jan LeCun just told us how we're going to reach a lot further heights. But I work at the Media Lab, and we focus on what technology does to our human lives, how technology affects the way we live our lives, the way we learn, work, take care of our health, communicate, relate to others, and so on. And so the question that I'm focused on, and a lot of my colleagues at the Media Lab as well, is as AI keeps advancing, how do we ensure that people will advance as well? And are we sure that people will actually also be better off in a world where they use AI all the time? You may know that by now, over half the US population uses AI on a regular basis, and frankly, it's almost hard to avoid using AI because it's integrated into every single app that we use and always eager to assist you with all sorts of tasks that you may be involved in. The promise is, of course, that AI will improve our lives, healthcare, education, accessibility, performance, our daily life at home, scientific research, etc. But I want to talk today about the reality. I think the reality is much more of a mixed bag of how AI is influencing our daily lives. There is an increased risk for misinformation and manipulation as we increasingly rely on AI to provide us with information. There's a loss of understanding and agency and control over our world. There's less interest and motivation for learning, and we are losing the skills that we once had because we rely too much on AI to do the work for us. We are weakening our social skills and our social ties to others as we increasingly just talk to chatbots for everything we need help with, rather than to friends or family or peers or experts. There are mental health issues such as delusions, even more serious problems like suicides, the result of our interactions with AI, and of course a loss of jobs, especially at the junior level, and a loss of meaning and pride in the work that we do, as we increasingly have to just be the people that check the work that is done by AI. So the AI gets to do the fun part, and we have to figure out what mistakes they've made because we're ultimately still held liable and responsible. So let me talk about all of these in a little bit more detail. AI's impact on human beliefs. You may have heard that AI has a sycophancy problem. AI systems basically prioritize agreeing with the user over issues rather than providing accurate information or objective information. And thereby, they reinforce some of the strange thoughts and beliefs that people may have. They reinforce biases, they spread misinformation, and they really limit people's critical thinking. Unfortunately, so the AI industry knows this actually, and unfortunately, in ChatGPT 5 is less sycophantic, but a lot of people rebelled because their AI was no longer acting as their best buddy that agreed with everything they said. They would occasionally push back. So people actually like these sycophantic AIs, even though they are not necessarily good for them. The sycophancy can result in delusional spirals, and we have learned what the negative impact is of social media, maybe 10 or so years after social media was introduced. I am predicting that with AI, we risk a similar, something worse than polarization, actually, and people just talking to people like them, in that ultimately we may have bubbles of one, where people just talk to their AI and live in this unrealistic world that they've created together with their AI. We all know that AI models are biased, and it turns out that working with an AI model that is biased affects your views and your decisions. A colleague of mine at Cornell, Mornaman, did a study where he just had people use a text editor with an AI assistant to write essays about climate change, and he gave people different AI models that were slightly biased in different ways, believing in climate change or not, or climate change being human-created, etc. And he saw that these biases were reflected in the essays that people wrote. And when he asked the subjects, did you realize that the AI was biased? They said, no. Do you stand by everything that you wrote in that article? Yes, those are my beliefs, those are my thoughts, even though he could clearly, in a using a statistical evaluation, shown that they basically had been influenced by the biased AI. AI is also impacting our decision-making. We did a study in my lab. We gave people a number of newspaper headlines. Some were true, some were false. We gave some people no AI. They had to decide themselves whether it was true or false. Others had an accurate AI or a truthful AI that said why something was true or false also. It gave an explanation. But then yet others, we gave a deceptive AI that gave them the opposite of the truth. And what we noticed is that people just trust AI. And in fact, often you hear people say explanations are so important. What we learned is if you provide explanations, people trust the wrong AI even more. They don't really look carefully about the explanation. They just trust that if the AI has an explanation for why something is true or false, well, it must be right. So we try to come up with new methods also in our lab, new designs for AI and AI deployments that actually will mitigate some of these problems. For example, a simple intervention where AI will first engage the user in asking a question about that newspaper headline. Do you really think the Pope would wear a Balenciaga jacket that costs thousands of dollars? That alone immediately improved their accuracy, even if they had an AI that ultimately would give a wrong suggestion. Now, agents are, of course, a thing in 2025. It turns out that all of these same problems exist with agents, but even at a worse level. We know from the work of behavioral economists that human choices can be manipulated, and in our work, some of the work funded by MGAIC, we show that LLM agents are even easier to influence in their decisions. So go see Manuel Cherub and his poster in the hallway later, who can tell you all about that work. In one example, we actually used AI assistants, just an AI assistant just to evaluate resumes for a job opening. And what we learned is that the exact same resume, if you have a famous last name, Kennedy, Gates, whatever, you get ranked higher than if you don't. So maybe think of changing your name in the era of AI. Learning and skill development. We did a study with 54 college students where we monitored brain activity while they were writing an essay on an SAT topic, actually. And we had 3 groups. One group used ChatGPT, another group just search, and the third group had to work by themselves. What we noticed in the EEG patterns were striking differences, a lot more connectivity and activity in the brains of the people that did not have the ChatGPT tool. But interestingly, we noticed some other things as well. We asked people to write about happiness. What does happiness mean to you? It turns out that the whole group that had ChatGPT to help them, they all wrote about how success in your career will lead to happiness. And we didn't see that as much in the other essays that were written by the other groups. So again, showing how AI actually influences your thinking, influences your beliefs. Worse, the people that had used ChatGPT could not quote from their essays or could not make that same argument orally later down the road. But yet, at the same time, they claimed ownership over this work. They said, yes, I stand by my essay that I wrote. This is my work, even though they couldn't even remember what they had written a week later. So we think there are solutions for this. Again, we are developing, for example, in the area of AI that assists with writing, a system called Critical Inker that acts more like an editor that tells you, this is a good point you're making, but you need more proof or more evidence for this point. Or maybe here you could use an example, etc. Teaching people to write rather than doing the thinking and writing for them. Now, AI is also resulting in the loss of skills, actually. A study done by other people, actually, showed that for oncologists who use AI for 3 months, they become less good at spotting cancerous spots in medical images because they rely so much on the AI that they lose their own skills that they previously had. Is this what we want, or do we want to benefit from both the expertise of the AI and the expertise of the doctor? We need to think about how to design these systems so that they really still engage the doctor and not just make it too easy to just rely on the system. So for AI deployments to be successful in a real context, it is not sufficient for the AI model to be accurate and fair and ethical and explainable. It is important that we also test AI models and AI systems in the context, the human context where they will be used, and that we look at other outcomes, not just how well the AI system does, but how well does that person do with AI? Do they lose their skills? Do they lose their motivation, etc.? I want to end by talking about some other work that we're doing as well on the impact on our social connections with others. You may have read a lot about that people are increasingly lonely, and I think that AI will only exacerbate that problem. In fact, if you look at the top AI apps, the ones that are about the AI being a buddy, a close companion, are the ones that get the most use. Guess where the money is going to go? I mean, all of these companies ultimately have to make a profit from the AIs that they are building. So we have actually funded by OpenAI, and in collaboration with OpenAI, done one of the first studies to evaluate how daily use of ChatGPT affects social and emotional outcomes. And we saw in a sample of 1,000 people using it for a whole month that the people who use AI more often in a day or for longer periods of time, they do report feeling less lonely, interestingly, but they also socialize less with other humans, which is a little bit worrisome. Together with OpenAI, actually, we came up with a new method for evaluating the social and emotional impact of AI models on people. And we now have classifiers that can actually look at interactions, conversations between the user and AI to figure out whether a model does well in terms of being more pro-social and encouraging the person to reach out to people rather than encouraging the person to just talk to the AI, for example. So in summary, AI's impact on our human experience, on our human lives, risks being negative unless we really think carefully about how to design AI and deploy AI and not just think about making AI ever more powerful and capable and then throwing it over the fence into the hands of real users. AI should present the truth and occasionally push back to the user and encourage a user to see other points of view rather than reinforcing their point of view. It should engage the users in critical thinking in areas where it's important that the person maintains that skill. It should stimulate curiosity and development of knowledge and skills, especially for young people, and should promote and support deep human relationships rather than aiming to replace human relationships. If you're interested in this issue, come and find me at the Media Lab. We have a large program actually with multiple faculty involved called Advancing Humans with AI, AHA, that focuses on designing AI so that people ultimately flourish. Thank you.